All right, so good morning, everyone, and welcome. I'm Dylan Tanzi, Executive Director of the SunSpec Alliance, and I'm pleased to welcome you to today's webinar entitled Reliable Monitoring and Remote Energy for Remote Energy Systems with HMS Networks. This webinar is being presented in partnership with one of our newest Alliance members, HMS Networks. I'll let the presenters introduce their work in the energy sector, but broadly, HMS is a large, globally traded company in the industrial ICT space, with fairly recent entry into the energy space. And to that end, they asked us if we could put up a little poll, and you'll see that in the top right corner. We wanted to ask if you've heard of them and their work yet in the energy space. So there's a little poll in this Google Meet window that you can click on. In the top right corner, there's a polls button. You can click on that and just mark yes or no if you've heard of HMS's entry here into the energy sector, or if you've heard of them more broadly. So if you followed SunSpec news and webinars over the last few years, you'll know that this is a bit of a change of pace, but also in many ways, it's a return to our roots. Recently, for obvious reasons, we've been very focused on using SunSpec standards for DER grid interconnection and integration. And that work helps utilities and grid operators connect to and control thousands of distributed systems, improving grid support, resilience, reliability, cybersecurity, and interconnection efficiency. Today, though, we're turning our attention to off-grid systems with remote monitoring. And that's a good reminder that SunSpec began as a de facto standards organization, where adoption has been, as has been the case for HMS, was driven by market demand rather than regulatory requirements. Standard communications aren't just about compliance or checking a box to get onto an approved equipment list. And along with the benefits I listed before, they also open new markets, help differentiate products, and they also drive innovation. And as you'll see today, this off-grid market is not just a side topic, it's a real and important opportunity, and one where standards, interoperable solutions matter a great deal. And so I'm not going to talk too much more, just a few housekeeping items before we hand it off to the HMS guys. So Davor, if you could change slides.
Yep.
All right, so all SunSpec meetings are conducted in accordance with the SunSpec antitrust policy and intellectual property provisions defined in the SunSpec member agreement. This agreement can be found at the following address. SunSpec strictly prohibits market participants and their employees who take part in these activities from using their participation as a forum for engaging in practices or communications that violate antitrust laws. Confidential or proprietary information should not be discussed in open session. Please contact SunSpec management if you have any questions. Couple final notes. This webinar is being recorded, so you will receive that in an email after this meeting, as well as will be posted onto our website and YouTube. To that end, please do keep yourself on mute to keep background noise to a minimum, and video off to keep the recording clean. Additionally, we ask that you do if you have any questions, put them in the chat, and we will be monitoring those and addressing them at the end of the webinar. And finally, as is always asked, these slides will also be distributed along with the recording when we distribute the recording. So with that, no further ado, I'm going to hand it off to Davor and Doug, and they can introduce their company and what they're working on. Take it away, guys.
Good. Thank you very much. Okay, so welcome to this webinar and presentation on remote asset monitoring and off-grid connectivity. So what we're going to talk about a little bit today, and I wanted just to start up a little with a brief presentation of HMS and give you a little bit of an introduction to who we are and what we do. So HMS is a hardware manufacturer. So what we do is we develop hardware which for communication devices, which is basically embedded where our customers are implementing our communication devices into their controllers, like a PLC or solar inverter or things like that. And we also do protocol translations. So we convert between different types of communication protocols. So for instance, between Modbus to Profinet, but also to CAN-based communications and OPC UA and so on. So our roots is basically driven from the ICT sector in terms of factory automation. And we then recently started to go more into the energy sector. You may be familiar with some of the brands that we have. So what we do is we do the gateway translators. We do that under different brands, which is Anybus. We also do remote connectivity for the remote gateways, where we have our EON brand. We do factory automation, building automation, and then we do switches and some ruggedized gateways in our Red Lion portfolio, and also some CAN-based communication with our brand Peak. So looking at the HMS with the history that we have is basically that we our main market is factory automation, and then we started to go into the power and energy sector a little bit more. And here we have actually mainly been working with off-grid applications. So where we have been connecting up, for instance, power generators, solar inverters, battery storage systems, but not really connected to the grid. So we are not really into the space of the IEC 68150 protocols. So, but that is something maybe that we will look into later on. Our main focus has been in regards to like off-grid assets and where we connect them and be able to remotely troubleshoot and so on and so forth. So a little bit on HMS. Basically, with what we have today is that we have enabled about 10 million devices, which are either implemented by our customers into their own products. And then we have about 600,000 devices which are actually connected to our cloud solutions to be able to remotely connect and remotely troubleshoot machines or devices. And then we also have within our building automation side, we have over 2 million devices which are connected like AC units, mainly for in Middle East, for instance. HMS has office. The main office is in Sweden, so it's a Swedish company. But we also have been growing through different types of acquisitions. And today we have offices in about 20 countries. And we also have both development and production in the US, in New York. And that is a little bit where most of the products that Doug is working with has its origin from there. And so we have about pretty good turnover. So we have been in the business for about since 1988. So we've been there a while during this whole connectivity transition. And maybe Doug, you can mention a little bit how we work in York and what are the products that we are doing there.
Yeah, we have a factory in York, Pennsylvania, about half hour south of Harrisburg, PA, and we build the Red Line and the Intran products there. We're actually starting to get some of the products from E1. I believe we're going to start getting manufactured over there as well. But we have SMT lines, we have assembly, we do from soup to nuts, from start to finish. We build HMIs, IoT type controllers that collect data, panel meters, things of that nature. So the factory's been around since 1972. So Red Line brand has been around for a long time, and the Intron brand was established in 1999. And now all that's built up there. It's about a 300,000 square foot facility. And we also have North American headquarters down the road there. We have a 4-story building full of people. So it's a great little facility, and we're happy to be part of HMS, which happened about 2 years ago.
Yeah, so HMS has grown through different types of acquisition, and Red Lion was the biggest one that we actually did. Okay, so a little bit what we're going to talk about during the here is basically a little bit like we said in the introduction, is that we actually are going to talk about off-grid connectivity, what we have in regards to a little bit sharing the experience when we have been talking to customers and what their requirements has been when we need to connect to different assets remotely, and what are some of the challenges when we are doing that. So that is a little bit what we're going to discuss a little bit and try to share with you. And if you have any questions, then put them in the chat, and we will then try to answer them at the end of the presentation. So when we're then talking about, because you need to start with statistics, every presentation has to do that. So the off-grid solar market is actually growing, and solar market in general is growing. There is some little bit stagnation in Europe in the solar market, but the off-grid market is actually growing quite well, and it's increasing. So we're going to have a CAGR of about 9.7. So it is a big market. And the same thing with the off-grid for battery storage systems is also a big market that is growing. So it's not just connecting to utilities, but it's a combination where the main drivers is actually to reduce with those applications where we have a battery storage system, solar, and a generator, where we actually want to reduce the fuel consumption from the generators, where we then combine more solutions together, and then be able to do a little bit more or saving a little bit more on the environmental side. So those are the little bit the main drivers. And also there are markets like telecom that is also driving the growth of battery storage systems. And the generator market has quite steady growth, and also it's driven more in terms of where you have rural areas that are going to be more, I would say, not industrialized. It's infrastructure that is being growing into.
We see a lot of the diesel generators also in data centers.
Yes,
that's where we're doing a lot of work with a lot of Redline products as well.
So that the market is growing, and I think this is also a space that where we have been growing quite a lot in the Middle East. That has been one of the markets that we have seen the biggest growth, where the combination of solar, battery, and generators. Those are the typical applications that we're getting involved in. Okay, so when we're looking at the energy sources, basically what we have is there is a lot of different protocols within the different applications. There is a lot of different communication protocols. So it's not just that we're looking at a great job that SunSpec is doing, trying to standardize, and it has also become a little bit of a de facto standard in terms of connecting energy sources. But in the different types of applications, there is a lot of different types of communication protocols that are actually used for the different types of applications to be able to solve that. So it's not just SunSpec Modbus, but it's a standard Modbus. We are talking about connecting, we need to be able to connect to using SNMP to connect to rectifiers. There is MQTT to be able to send that data off, and also be able to convert between different types of protocols like OpenCUA. So there is a lot of different types of communication protocols within those applications. So it's not, it's a great way that SunSpec is trying to standardize, and I think that is also one of the reasons why we are in this segment, is that trying to solve the applications in a much easier way. And I think here is also where we do a lot of these types of translation between different types of protocols. Something that you want to add, Doug, into this?
Yeah, a lot of these, almost every one of these protocols that are up here, we're able to do with our products. We integrate very well with all these different industries, with a particular, focus, like Davor was saying, pump stations. We can do wind turbines. We're involved in all these different utilities, and besides the 61850, everything else here we're pretty deep into. So we have a lot of products that can interact and gather a lot of data, and using these protocols, you can actually, reduce your bandwidth and increase your speeds. So we're pretty in tune with it.
So what we have also is that within those applications, you need to be able to support a lot of different types of communication protocols, and that is a little bit where the origin and expertise from HMS has come in. That is basically where we need to convert between Modbus to OpenCUA, for instance. So if we move into the space of, and a lot of times I would say a little bit, when we are talking about communication and we're talking about remote, a lot of times people think of it as like you connect it to some equipment which is up on a mountain somewhere in Alaska, for instance, or on a remote island. But we have had like applications where there is like a factory, or there is a business center that has been running off grid because of construction works during 3 years. And basically you still have like a solar, you have a battery storage system and a generator, which is feeding the power to the building complex, for instance. So it doesn't, off grid doesn't mean that it has to be very, very remote. You still have the same challenges. So when we then look into the key factors when we talk about off-grid and remote installations, basically what we have here is that the issue we have is standardization. Is that you have, in those type of applications, you have a lot of different types of equipment. You want to be able to standardize that in a one way to be able to so regardless which product you're connecting, you want to have one solution to be able to monitor all those solutions, systems. And that means that the system has to be able to cope with a lot of different types of assets. And then we usually work a lot with that. You need to monitor a lot of different, a lot of the same type of devices. So the scalability on how you are able to monitor a lot of assets. And within HMS, we a little bit joke about it that you have one asset, one is easy to monitor, but 1,000 has its biggest challenge. And then what you also have is that there is no one system that works with everything. So you need to be able to collect the data and be able to integrate that into other systems. And most of the time when we work with off-grid installations, it also means that we are using mobile networks to do this. And with the mobile networks, that if you have a lot of different types of assets, it also means that you need to consider operation costs. And it's always this balance between access to the data and the operation cost, because everything, the transmitting is also being has a price to it. So there is always this balance between the data that you want to receive and the operation cost. So when we then connecting up the different assets over the networks, and we usually do that over 4G, there is you have challenges with that. So what happens is when you are connecting up a device to the remotely, and you're relying on 4G connectivity, for instance, there is a lot of challenges with that you need to consider, because that's one part of the data chain that you actually are not in control of most of the time. And that means that you need to be able to have strategies in terms of how to store information if you lose the connection to the cell tower. It also means that you will be disconnected from the cell tower, because a lot of times what happens is that within in a construction site, for instance, or on festivals, or you have other applications where you have a lot of people connecting to the same cell tower, the cell tower will have some network congestion and you will be kicked out. So then the devices that you want to connect, that is collecting the data, needs to be able to re-establish the connection to the cell tower and do that automatically. But it also means that if you don't send the data in terms of from the device to the cell tower, so let's say that you're just logging data in let's say once a minute or every 5 minutes or something like that, then the cell tower will also detect that you're not transmitting to, often enough, and it also will be disconnecting. So that is also parts that you need to then consider. And a little bit also that you can have good signal quality. So that signal quality means that you have a good signal, so the messages are coming through correctly, but you have low signal strength. That means that you have maybe delays and latencies. So there's a lot of parameters which comes into play when we are doing remote connections. And also, if you then have, for instance, that you don't have a 4G reception, that you may need to have alternatives like satellite communication and so on and so forth. So these are parts of the challenges, and I think this is the biggest challenge that you have when you're doing remote connectivity, is that you're not in control of the complete data value chain, or the data chain from the asset that you're connecting till you get it where you want. And this is also a little bit comes into where you then can have strategies, so you can use lightweight protocols like MQTT, for instance, to be able to transmit that data from the devices. And also you need to have be able to store the information locally onto a gateway or something like that, in the event that you're losing the data connection.
Yeah, you're going to lose connection. There's no doubt about it. There's going to be different connection situations, like you said, between the network congestion or maybe lack of back and forth with the network. At times, you may get kicked out. The good thing is with a protocol like MQTT, and if you're using like a Spark-Plug-B connector, you can actually save all that information. It's not that the application stops working and you're losing the data. You still have the data. When you make reconnection up to the cell connection, it will actually backfill all that information. So it's those things are really important, and that's a great way, and one of the strategies that we do a lot of in our work is using that type of lightweight protocol to be able to make sure you don't lose data. You continue to gather the data even when connection is lost. So we highly recommend that.
A little bit is also, if you look at the graph which is presented on this slide here, is you see that it's disconnected. And one thing that you may discover is that you will be disconnected on a regular basis. So there's cell towers which are disconnecting you every 5 minutes. So you need to be able to maintain connections. Sometimes you need to increase a heartbeat to be able to maintain that connection. Otherwise, the cell tower will disconnect you. So there are strategies to be able to change the heartbeat data sender to maintain a connection is important to be able to maintain that connection, so you don't have to retransmit. And this comes back also that if you don't need to retransmit, then it's also you're reducing the operation costs. So I would say that this part here is the biggest challenge, because you don't have the control of the connection. What you can work with then is that you can try to work a little bit also with how we store the data. So a lot of times when we have, for instance, we need to send the because we are relying on the data for the state of the device that we are connecting to. So here we can then put in some strategies in terms of how we're collecting the data. So we can reduce the operation cost, because the more the devices that we have, we still need to consider the operation costs. So here we can then, for instance, gateways could configure up so they send the data like every minute or every 5 minutes, depending on what type of parameter it is. But you can also have like hysteresis, where we only log data when it changes a certain amount. Maybe do storing consumption data on the device, and then just sending the consumption parameter instead of sending sampled and do the calculation later. So it reduces the data transfer. Runtime is basically that you can want to be able to log time on the edge to be able to see, okay, has the temperature been above 27 degrees, for instance, then you want to be able to accumulate that, and then on the edge, and then after that, you want to be able to see what has been the total amount of time that the temperature has been about 27 degrees or running hours or whatever it may be, and then get a notification. So you try to implement as much intelligence on the edge, so you don't need to transmit it. And same thing with condition-based logging is that you only log data when something happens. So let's say that you are monitoring a power generator in this
Conditions
case.
matter, or there's some change in state. That's generally the best practice, because if you're just continually sending data out, you're going to spend a lot of money on data you don't even need. And a lot of times we find that most people are really more interested in whether a condition was met, whether something's on or off, or a change of state that is critical. And you know, the next thing is you're going to need some alarms set up. So I think that this is really important for saving money, but also getting the type of information that you need. Condition-based and hysteresis data are really the two biggest ones that we see the most of.
So I think, and this is also comes back to, because if you're like in an environment like inside a factory, you don't have these restrictions. You can send as much as possible because you don't
You're
have
connected straight to the SCADA system already. You're right there. Yeah.
So here we have other things that we need to take into consideration. Also, a little bit on like data compression and aggregation. So here what we are talking about is that all the data that we're sampling. So on the edge, we try to do some calculations, compress the data, sending just partial data, the aggregated data to the system. And then from there, we to be able to reduce the operation costs. I'm coming back to operation costs quite a lot, but this is a little bit where there are other, once you start to collect the data into IoT solution, you have other costs. So you try to make the data that you're collecting as efficient as possible, and you can do that on the edge as much as possible. Is the main strategy. So yeah.
Yeah, I think I love the flow of this, because that raw data is what we're talking about. That's great, but a lot of times you don't need all that data. You can compress that down into a smaller bites, and then from there actually get the data you truly want and start aggregating that data in chunks that make sense for, you know, an operator or back at a control center would want. And then you optimize that data as you're sending it, and reduces bandwidth, lowers your costs, and of course, fewer transmissions means less money that you're having to spend to get the actual information you truly want. So,
yeah. Okay, and then what we talked about a little bit earlier is like when we are disconnected from the mobile networks, because that is what we rely on. We still need to be able to do local buffering on the edge. We need to have store and forward principles in place, and then be able to, once we get the connection back, upload that data. So I think the connectivity disruption does not mean data loss. I think that's a really good way of thinking it, is that you want to be able to make sure that the data on the site that you are monitoring, that data is actually being transmitted and being collected. So on regulatory purposes, and also for then data integrity.
the key to this being the store and forward. You know, you're still collecting the data even if you lose the connectivity. You're still storing it locally on a device, and maybe in the memory that it has, or an SD card, what have you. And it'll backfill in once you get the connectivity back up. It's really important to have that type of device and use that type of connectivity strategies.
So one thing that we wanted to highlight also is a little bit the essence of metadata. So when we are connecting, for instance, we have a device, a gateway, and then we have the same type of device which is connected behind it. So let's say we have these controllers, but it could be any device. But if you then have, for instance, 3 controllers which have the same Modbus template, you need to be able to, when you won't be able to distinguish which data parameter comes from which device. So here it's what you want to do is you want to be able to tag up those parameters on the edge, so you can see, okay, this voltage came from this specific device with Modbus, even if it has Modbus label 1. I want to be able to backtrace that information when I'm transmitting it later. So I know that it is from this device that this voltage reading came from. And if I then need to replace the controller, I can still utilize the same configurations. So because those ones don't need to be linked from like a Modbus register perspective, because you have added the metadata on top of it inside the gateway before you transmitting it further on. So when you're then collecting that data to do further analysis, you know from which device it has come from. I think this is one really important part, that specifically when you have a lot of the same type of devices that is connected, and you want to send up the data up to a cloud solution, whatever it is. We also, when we're talking about data collections and remote connectivity, there are like 2 main types of gateways that there are a little bit of different strategies around it, but it also they have both their benefits and disadvantages when we are collecting data or trying to do remote connectivity. So one is where you do the local configure device, where you browse into the device. There is some sort of a web interface. You can then do your configuration of the parameters, and then you send that off somewhere. Now that means that you need to transmit everything into from the device, because the intelligence is on the device, and you need to transmit it to some sort of cloud solution or whatever it is. You usually use those types of gateways where you then have a closed environment where you are not connected to the public internet, or you're not allowed to do that. Then those types of gateways are really, really good to be used in those types of applications. The benefit
I also think the cloud is those are excellent when you're doing mobile applications, because you got to go, you're remotely connecting anyway. So that's where we see that being really important. If you're configuring up in the cloud, you have mobile applications, you can have from device to device anyway, no matter where it's at. So I think that configuration's kind of an advantage for those types of applications, whereas the local kind of works a little bit better in applications where you're in a certain area. It may be remote, but you can actually configure even if you don't have access to the internet at that particular time. So that's some of the big advantages between the two, in my opinion.
Yeah. So what you have is that one of the advantages with having a cloud configured device is that your configuration stays in the cloud, and you can then have remote access to the devices, and you can then select which parameters you want to actually retrieve the data from. So it's more of the performance data, because a lot of devices, what they have is they have a lot of set points. They have a lot of different types of configurations, which you rarely use, but you still want to have access to them. So by having the whole configuration in the Modbus template or so in the cloud, you can then from the cloud request the data on demand, so to see okay, what are the set points, but then the performance data the gateway will manage and just send up those types of parameters which you're interested in. And also it means that you're reducing the amount of data traffic which goes back and forth. So it has both the local device has its advantages and disadvantages, and the same thing with the cloud. You have to think of a little bit, you can get some delays and stuff like that. So those are like the 2 main strategies when doing remote connectivity. and be able to trying to access different types of remote equipment. So, but we work with both types. So that is so we try to fulfill those different types of requirements that we have. We also then a key important part is that trying to do alarming on the edge is also important, because you want to be able to, a lot of times you have to differentiate between logging and alarms. That's not really the same thing. So a lot of times what you have is depends on where you want to have the intelligence. If you want to have the intelligence on the edge, or if you want to have the intelligence on the cloud, for instance, or in the management system, so to speak. So if you want to do the thing on the cloud where the intelligence is, then you need to be able to access all the data that is being from the remote site to the management system, this cloud solution, whatever it is, and then they make the decision. That system makes the decision of what is going to happen. If there is an alarm notification that's going to be sent off, or if it is this parameter above a certain threshold. The advantages with having that intelligence on the actual device is that you only transmit the things that is really important. And then also when you're combining information from, for instance, from a battery storage system and generate the solar, is that you can then combine that if the fuel level is low on the generator and the state of charge is low, then I want to have and it's dark outside, then I want to get the notification. So, and based on that, you want to have some local control that then starts up the generator or sends a notification or something like that. But also, so it's really important, I think, that to have the intelligence of the alarm management on the edge. But also, alarms is like offline alarms. Let's say that you have, you're communicating with a remote site and you're being disconnected from the 4G network. Then you will not know if everything is okay or not. Then you have a cloud solution that will detect that it's lost the connectivity part with the device and then sends you a notification. So there's a lot of other systems in place that needs to be considered to be able to solve those different types of common challenges, which comes from just doing like a remote connections to remote assets. Moving in a little bit also, one part is that when we're talking about the Modbus, because we're talking about SunSpec Modbus also, is that it's you can do troubleshooting of remotely of a Modbus connection line, for instance. So let's say that you're running Modbus RTU. So you can have be able to a nice feature is to be able to if you have different devices connected, then you can troubleshoot it based on, okay, do I get timeouts? Do I get the CLC errors and things like that? Then it's easy to pinpoint where the connection is down, and then you can try to solve that. But you have tools to be able to troubleshoot Modbus connectivity as well remotely. And this is one of those things that we do quite a lot, because things happen over time and there's nobody on site. So it's a good way to see, okay, is the communication running? But it can also be that the connection is loose for some reason. So sometimes it works, sometimes it doesn't. So remote troubleshooting is possible to do as well. We then have the possibility to do remote access. So remote access is basically that you can, let's say you have your battery storage system, is that to be able to remotely, using the tools of the manufacturer, be able to connect over the internet to the equipment and using those tools to be able to troubleshoot it. So here you can then, for instance, do much deeper troubleshooting. You can extract the files, you can do reconfiguration, but it also be able to connect to like a web camera or something. So if you need to remotely start and stop something, so you don't want to have somebody let's say you want to start up a generator, you don't want to have a technician or somebody with his hand inside the engine. So then you can access the remotely to be able to troubleshoot and to be able to control a device remotely as well. So this is quite a handy tool when dealing with remote assets. So what are the alternatives? So we have talked a little bit about a lot of in regards to 4G connectivity, but there are other systems, of course, and there are a lot in regards to the low energy alternatives like LoRaWAN, narrowband IoT, Cat-M1, and so on and so forth. But in a lot of the applications that we have been involved in is basically mainly around 4G. And standard mobile networks, because most of the customers that we have been working with, they require much deeper analysis, the things that they want to be able to access on the battery storage system or on the generator side or on the solar inverter. It requires that you actually have higher bandwidth, and that the low power systems that mainly are limited to like the data transfer, and also that it's mainly intended for battery powered, and so it basically gives you just status updates. Okay. So the dealing also with the remote, it requires that you need to consider a little bit on the power strategies. So sometimes what you can do is you can have devices that goes into sleep mode. So they load some data and then send it off, go sleeps, and then wakes up after an hour, and then reads some data and transmits that as well. And when we're dealing with remote sites, there's a lot of times we also have power, which is maybe not stable. So here also the devices need to be able to have cope with the extended power range, but also when we have been doing installations in the Middle East, where the temperature between day and night varies quite a lot, the devices need to have like extended temperature range.
Yeah, extended temperature range, wide voltage input range. This is so you can actually work off of a battery around 10 volts, or even an overvoltage situation from a small power supply or what have you. And it can take dirty power. These things need to have surge protection and things of that nature as well, so it can actually clean that power as it's going into the device and work it. So all these are very common things in a remote application where you got low power, you're relying on solar to continually charge those batteries, and also the wide temperature ranges to be able to handle something in extreme cold or extreme heat. Otherwise they're not going to survive, and you're not going to be able to work in these harsher environments.
So it's sometimes a little bit more challenging, and I think that is, and this is like Doug's expertise that he likes to work with. So this maybe Doug, you can
sure. Yeah, a lot of the things that are made by the Red Lion side of the business are able to do up to 350 different protocols. So you could do anywhere from a Siemens connecting to an Allen Bradley Rockwell type PLC to Modbus to DMP3, MQTT. So it's got a wide capability of being able to take inputs in and then talk to a PLC, a drive, a meter, whatever it is that you have to. You're also able to have a wide variety of different connectivity capabilities. So you're able to talk to SCADA systems, servers in the cloud. These are all pre-built drivers, and the configuration parameters are pretty straightforward and easy to use, and it's part of the operating system as well as the software, which is included. So lots of excellent ways to communicate. Really important to have something versatile that you can do a lot of different things with, and that's kind of what the product line brings to the table. With protocol conversion, it's really important because you can do multiple protocols on one device, which is I think extremely important.
And I think this is also where it comes in, where we were talking about these different assets, or we talk about applications where you have not just one specific type of equipment. You have maybe a PLC, which is supposed to control something. You have some sort of power source, like a generator or battery storage system, where you maybe are talking both Modbus and you're talking CAN, and
you might be talking CAN. Yeah, you might be having to talk to an inverter that's you know, helping to run a solar panel, and these things all interconnect, and you're able to do that with one system, which is really important.
Yeah. So the possibility is a lot of requirements to fulfill a certain application requires a lot of times also to a typical one is like every battery storage system container has aircon unit or a chiller inside. So you want to be able to monitor the chiller as well. That one is usually has also like Modbus in it, or it can have some other type of protocol. But you also want to be able from that remote asset be able to connect both to the Modbus, but also to the other protocols that are available on those types of systems.
And you need to be able to do that simultaneously as well. That's the other thing that's important there. So your latency is very little.
Yeah. So then, I mean, this is a little bit what is a lot of times required as well, because what we see is that there's a switch, not just from doing monitoring and things like that. It's just there is a bigger demand as well for on remote sites to be able to do control as well. So here is it's important to be able to take in the data from the different types of devices and then become a little bit of a site manager, where you then reading data from the generator, you're reading data from the solar controller and from the battery storage, and then switch between who is supposed to supply the power, for instance. But also the different doing some calculations, aggregation in terms of the data points that is on that specific site. It's not the aggregation in terms of from a lot of assets that you do more in terms of into the cloud.
Yeah, I mean, this is kind of, again, a nice depiction of a lot of different functionality able to be done within one device, and again, the filtering of the data is extremely important, so you're not getting overcharged for data you don't need, and being able to talk to multiple systems like we were talking about in the prior slides. So, you know, anywhere from doing ladder logic function block, you know, scripting, to the aggregation of all the data you're collecting based on different sensors and different inputs you're getting from different systems. So real good stuff.
Okay, and yeah, so this is basically like an example of like where you have a generator, battery storage system, solar panel, and then from there you want to be able to visualize that, getting that data into some other system to do some analysis. And one of the examples we have is, for instance, where we have customers doing exactly this is in the Middle East, where they go to, for instance, to a factory, for instance, and they then combine solar, battery, and generators to supply them the energy. So then what they do is we become the site manager, and then what they do is basically controlling which source is supposed to feed to the load. So this is a larger request for specifically for off-grid applications.
Yeah, one of the things we talk about on that past slide is being the conduit for all these different systems. We may not be doing all the aggregation like they're doing over at the office control center, but we're actually connecting all that data, getting them all that information so they can actually use it properly. So we may use the term aggregation a little bit different than sometimes they use it maybe in the power industry, but being able to connect all these, get all that information, gather it, and properly disperse it to the different systems is what we're really seeing as an important tool and something that we do a lot of.
Okay. So what we have done is basically within with SunSpec and HMS is basically what we one of our solutions. We have a small template tool. So basically what we do is we have the Modbus registers, and basically what we have is a little script that we can deploy to the gateway, which then reads if the device supports SunSpec Modbus, and then we can it comes back with a list of which models are available on that device. We can then assign those models to that template, and then you can, with the offset, and then from there you can upload it to our cloud, deploy it to the device, and do the configuration of the alarms and things like that. So that's the implementation that we have done so far, and then we are looking to do more in the future. So this is a little bit of the starting point for us. Yeah, so a little bit key takeaways is basically when working with remote devices, remote assets, and so on and so forth, the most important part to understand is that you're not in control of the whole connection. Specifically, when you're working with actual mobile networks, you need to have local strategies to store the data inside the gateway or in a device. You need to be able to send that data forward once the connection is re-established. You need to be able to detect if the device is offline, for instance, and you need to also have a ruggedized hardware to be able to do that. So the system that is collecting data needs to be designed for those types of applications. So where the extended temperature range or voltages is important. And then there is a multi-connectivity path. So the data needs to be transmitted to a lot of different ways, but there is a lot of different data connections to the different assets that needs to be combined with and be transmitted. So looking from an application point of view. So I hope that you have a little bit better understanding of the challenges which comes with connecting to different types of remote assets. It's a very fun and interesting line of business, and I think that with assets, off-grid assets is growing, and I think this is a really interesting part that we would like to be have greater focus on in the future as well.
Yeah,
this
is great, Davor and Doug. Thank you for your presentation today. And I think one of my key takeaways is that these off-grid systems and industrial systems like what you guys service is equally complex as what we sit on the grid interconnection side, with just the complexity of different data sources that you're aggregating, and just the same way the benefits of standardization are evident. And unlike a lot of our members who come to us through interconnection requirements with regulatory mandates, just one quick question: what brought you? How did SunSpec get on your radar, and what brought you to join?
It mainly started up that we saw a lot of equipment supporting SunSpec, and a lot of our customers started to utilize devices that were doing SunSpec, have implemented SunSpec Modbus. So that was a little bit where we see that we need to be able to support that as well, and I think that is also really important if you want to be part of like the energy market and you want to focus on that, then you need to be part of the SunSpec Alliance, because I think that is if you want to understand where the market is going and also the different types of challenges. I think there is a lot of great work that SunSpec is doing.
Great, it's really gratifying to hear, and so thank you for those comments. I do see we have a couple questions in the chat. So Sam, if you want to
yep, absolutely. We've got a couple questions and one comment here. Oh, and one more question just came in. We'll start here with Mosin's question. As more AI applications move closer to operational environments, how is HMS thinking about edge AI architectures? Do you see AI running locally in gateways/controllers during cloud disconnection scenarios?
Yes, I think AI is it's interesting area. I think one of the bigger challenges is that with AI, I think first of all, I think AI will be implemented into the edge more and more into the
I do
edge
too.
devices.
Yeah.
And I think that the biggest challenge that you have is the data that you're collecting. To be able to create AI models and to be able to deploy that, first of all, you need to know what is the problem that you're trying to solve. You need to have a clear view what the AI is supposed to do for you. And I think that it's within specifically for the applications that we are in is where we are doing a lot of off-grid. There is a lot of you need to collect the data first, and you need to have proper data, and you need to be able to have a lot of it. And that is, I think, the biggest challenge, to get a lot of data from the remote devices, because you have this constraints in terms of operation costs and things like that. I think, and once you have collected up that data, you need to then do the modeling in the cloud somewhere, and then be able to deploy that into the devices. That is where I see that AI is going to be used. And we have played around with edge computing, so where we have some machine learning algorithms that we have played around with a little bit on the devices. And I think that the biggest challenges in the area is data control. I think this is a little bit what is going to hinder a little bit, I think, AI development moving on, because for AI to be able to develop good models, you need to have the data, and then the question is who owns the data. I think that is a discussion that will come into play much more. So, but yes, AI is definitely coming to the devices.
Great.
I hope
Thank you.
that was a little bit of an answer.
Now we are at time. Do you guys mind taking a few more questions?
Yeah, that's fine.
Okay, great. So one more question here will segue. Does HMS also get involved in establishing NERC CIP compliance for USA power generation projects? And if so, how is it achieved?
And before you answer that, just you go to the next slide, because I do think once we get past the hour, some people start trickling off. So go ahead and put your contact information up there so people can get.
Yeah, okay.
Yeah, there you go.
Great. Thanks, Dylan.
Yeah.
So you want me to ask that again real quick?
Yeah, do that.
Does HMS also get involved in establishing NERC CIP compliance for USA power generation projects? And if so, how is it achieved?
Not that I'm aware of at the moment.
Yeah, not so much. I mean, we get into CIP messaging with Ethernet switches, based on, the ODVA and working with Rockwell controllers, but that's more on the networking only side. Not so much with any of the control products or whatever we do.
Great, thank you. And then we had a comment here. I'm not sure if either of you are familiar with this, but someone linked a YouTube video regarding the use of solar battery drones that fly in the stratosphere, transmitting cell phone data where no tower network or Earth orbiting satellites are required. Is this something that you guys are familiar with?
I would not. I would say no.
Okay.
I would have to say no too. It sounds pretty cool though.
I didn't think so. Yeah, there's a link in there from the chat, so feel free to explore that. And then we just had one more question come in, and that is, what is HMS's current capability and limitations for on-grid solar farms? How do both on-grid and off-grid solar farm data monitoring differ?
It's mainly how they are connected to, I mean, we can monitor pretty much anything.
Yeah.
The interconnection between the production to the grid that we don't do. So that's the part that we have not really been involved in. We had devices in the past for IC 6850, but when we looked at that many years ago, we never really got in contact with those types of applications. So that was from an acquisition that we did in the past. So I would not say that there is not a big difference. It's the interconnection between when you're connecting up the solar panel to the system to the grid. That part we are not really involved in. But to connect to an inverter or something else, that's usually just the way that we connect up pretty much anything else.
Great, thank you. And we'll just close with one last question here around AI. You mentioned connectivity challenges between the field and the cloud. How does HMS handle AI or analytics applications at the edge when connectivity is lost? Do you support any local AI inference or autonomous edge decision-making capabilities?
We do that. I mean, a little bit, if you lose the connection, basically what you do is you configure up the gateway to based on either you do a program inside the unit or there's some sort of scripts, and then that will still work without, even if you lose the connection. So you still have local intelligence on the device. So it's so that will work regardless if you lose the connection to the cloud, for instance. That will still work. And
yeah, we would basically take that information and store it down to the SD card, and then once the connection's reestablished, it would backfill that information that was lost during that time period back in. That could be minutes, that could be hours. We can put a pretty large SD card into our devices, so that's how we would do it. We wouldn't need AI to do that for us, but if there's moving forward as we get into other technologies, that I'm sure that'll be integrated in.
I mean, I think also it's like when you talk about AI is such a broad
statement. Yeah,
it's a broad statement. And I think that, I think in a lot of the discussion that we've had is that everybody's talking about the type of customers and applications that we get into is basically like there's a lot of talk about AI. There is a lot of talk that we want to do this, or what do you do within AI? Then when you ask them, okay, what is that you're trying to accomplish? What is the actual solution that you want to achieve, or the problem that you're trying to solve? Then a lot of times it's like basic logic. It's basically some sort of calculation on the edge. It's not super advanced at the moment. So so it depends a little bit on the application. But so AI is a quite broad term, but when you start to dig down to it, a lot of times it's not super complex. I hope that's but I think that the more stuff you connect up and the more data that you're collecting, the more AI will help you to do stuff better.
To be able to sift through the data and actually collect what you're looking for and be able to filter it out. Yeah,
but
I agree.
But you do that also a lot right now in regards
some of the aggregation.
The way that you log data, that's not really a big difference. It's just a different techniques to do that. So I think that I think that AI will come. I think that I think the key question is what is the problem that you're trying to solve? And there are a lot of strategies that you can do for that.
Great, thank you so much, Davor, Doug, and Dylan. That's some good alliteration there. Thanks again for coming over. I'd like to thank everyone. Yep, thanks everyone for joining today. As Dylan stated before, the recording will be made available as well as the deck on our website and on YouTube. So once again, we just wanted to thank you all for joining. Thank you for your time and your questions. And thank you to our presenter for the great content. And I hope everyone has a great rest of their day.
Yeah, thank you.
Absolutely.
Thanks everybody.
Sam. Thank you. I appreciate it.